Hey guys, welcome to the shop now. In this video, we're going to be trying to finish up the clutch shaft that we've been working on for the last couple weeks for our K&T mill. We got to find the tapered pinhole that the original one had and transfer it to the new shaft that we made, get it pinned to the shift fork, and reinstalled back in the gearbox. So that could be, kind of sketchy or kind of tough. I don't know. We'll see. I've got some viewer mail to share with you, and of course, probably a couple other things. So let's get started. I think I'm going to weld up the original shaft in its original alignment. That way I have something to reference off of. And set it up in the milling machine. And then hopefully I can transfer shafts back and forth and get an accurate placement of that tapered pinhole, because it's really not that straightforward. At least it doesn't seem that way. So let me get this up on to the shaper table. It's going to be kind of a job, and then we'll weld up the original shaft and then get set up in the milling machine to transfer that hole. Alright, so here's a look at the damaged, gear here. And I mean, it's not that bad. It's just where, they two engage with each other. I'm assuming where it had clutch shaft damage, they tried to operate this thing without it completely disengaging. That's just an assumption. But any of you guys who have a lot of experience with gears and stuff, should I try to dress these, do you think, with a die grinder? Because right now I'm sure it's got a lot of pressure points, and I wonder if I smoothed those over, just, cleaned them up with a die grinder. I wonder if that would help this last longer. Not that it's going to be an issue. This thing will probably outlast me 3 times if it's cared for at all, but you know what I mean. While it's out, if I can remedy this, I would like to. Hopefully, that's a focused shot. Hard to tell with a GoPro, but these close shots don't do too well. Move it back a little. Yeah, see, it's not horrible, but if I can maybe take a die grinder and a little stone and just clean those up, I would like to do that if it is necessary, or if should I just leave it alone. Here is the original shaft, and man, it's a cobbled mess where it separated or broke, but that does allow me to key it up or align it back in its original position. So I'm going to take this out, and I'm going to cut a couple slots in it, weld it, and machine it back down. Just not going to weld it to like I was trying to repair it. Just weld it to where it's all together in alignment. And then I'm going to try to set up in the milling machine and transfer this tapered pinhole into this shaft, because that's all it needs. Alright, so my plan is just to weld this thing up strong enough to where it'll hold for assembly and alignment needs. And first thing I'm going to do is just tack it in 4 spots, just not real heavy, just heavy enough to hold it in a line, because I want to keep this thing as straight as I can. But welding on something does not usually end in a straight part, but we're going to try our best. I don't have a clamp long enough to sandwich this thing together, so I'm just going to do the best I can. And we're going to be using my Harbor Freight welder. Now, it's a tick stick. 165 amps, I think. I've had this thing for a couple years, and I use it, like a home shop every so often, and never had the first problem with it. I did do some stuff to it in the beginning, but it's been a good welder, to be honest. But one of these days I'll get something good. I'm used to welding with the Dynasty 200 at work, a Miller. That thing will spoil you. So, yeah, got it lined up in the original position. Just a light little tack, just enough to hold it. And I'm gonna just use my finger, because I know that it pulled a little at least. And I use my finger and push back the other way, hopefully not break the weld that I just put on because it's so little. Now I'm just going to cut into that place where the two meet and then put a little heavier weld into it to hold it together while I try to assemble it. Man, this thing is so full of just oil and goo in that crack. Look how sooty it's getting. Just horribly dirty, but you know, I tried cleaning it. I can't clean it any better than what I did. All that goo coming out of it. Alright, whatever. Just for assembly, I'm going to take it to the lathe. I'm going to spin that weld off. That's the reason I cut into it, so I can spin it back down to its original size and still have some strength. And then we'll try to get set up in the milling machine and transfer our holes. Ooh, it's a little hot. Let's stick this thing in here and turn off that weld. Hopefully this thing's not too crazy. But when I tacked it, you know, I made sure just to lightly just tack, then 180 degrees, push it, tack, you know, and so on, you know, around. That way it kind of stays where it should be. Actually doesn't look too bad. Okay, hopefully see that. Oh, a little over 4 thou, man, you can't beat that. That's actually a lot better than I was expecting. So, not too bad. You know, we got a little room for error. I'm going to turn down this weld shoulder, or this excess weld, back to the shoulder, and then we will figure out what to do next. Turn it down a little more than what it really needs to be. It's not going to make any difference. All I want this part to do is hold on. Alright, so here's my setup in order to try to get this hole into our new shaft. This is the original. And then, man, this has been really testing because this hole is not in the center of the shaft. It's not in line with any of the original features. You know, I'm having to try to, you know, find out where it is. And I think I got something that'll work. But if you was to say, well, how do you think they done it? I just seen a mouse. How do you, when it gets cold, they come in. I've got a few running around here. If you said, Steve, how do you think they done it originally? I would say they hand drilled this thing. From the looks of it, I would swear they put this thing together, they ran a hand drill down in it, reamed it, and drove a pin in it. But I think that I've got this setup that will work. So let me bring you around. I want to show you what I've got here, and then hopefully we'll transfer these shafts and drill it. Alright, now let me show you how I plan to get back into the original hole in the shaft and replicate it on our new one. And this is just the best setup I can come up with. It won't get us perfect, but it should get us close enough to where, you know, it works, and that's really all I'm worried about. So I've got a positive stop here bolted to the table. I've got my rotary table set on 0. I'm bumping up against the stop with the end of the shaft, and I'm just going to snug lightly the chuck against the shaft. Take my Starrett number 20 square and square the tops of these gear teeth with the mill table, just as best as I can by eye, and it's, you know, it seems to be giving me repeatable results when I pull this in and out. All right, so square. Now I need to rotate this rotary table 3 degrees clockwise and 34 minutes. And that should allow this tapered reamer to slide down into this hole and be aligned, and it is. What I forgot to mention originally when I was trying to explain this is that I established that the reamer was straight up and down by putting it in the original hole that's in this shaft and then sweeping it with a coaxial indicator and a indicall with the spindle of the machine, and making sure it was, you know, true with the spindle, and then, you know, seeing what my readings were on the rotary table. So it was a long time, took me a long time to get this set up, but I think that it's pretty good and will work. So I'm happy with that. So now all I need to do in order to get an accurate placement, relatively accurate placement on my new shaft is go through the same procedure. Zero my rotary table. Now the original tapered pin in this shaft, according to the documentation on the mill, should have been a number 5. It happens to be a number 6 because they've been into it before. So 0 the table. Bump up against my stop. Dimensionally, this shaft is the same as the other, so it should give me a fairly accurate placement. Square the teeth with the table. Tighten it down. Rotate 3 minutes. 3 minutes. 3 degrees. 34 minutes. What am I thinking? Okay, so now I can take my drill and drill a hole in this shaft and then ream the hole. I'm going to be doing all of my reaming on the actual machine. All I'm going to do is drill the required hole in the shaft and then assemble the pieces on the mill and hand ream it. That way everything, you know, is in its natural position. Now as far as drilling a hole for a tapered pin reamer, it's you know, kind of, you know, it's more complicated than what you would think. This happens to be a tapered flute tapered pin reamer, or a spiral flute tapered pin reamer, and they don't seem to require step drilling like a straight fluted tapered pin reamer would. There's a lot to it. It's not as simple as just drilling a hole in most cases, depending on your hole length and stuff. And a lot of tapered pin reamers will require actually 3 drills, you know, 3 different sizes to give you, you know, a according to the paperwork, the hole that you really want. So I did some test pieces. It seems like this drill, considering we're only drilling through a really short piece here, gives me good results because, you know, I'm testing all this before I do it. So that's what we're going to do. I'm going to spot it, center drill it, pilot drill it, take this out, take it to the mill, and hand reamer hole. That's the plan anyway, so let's get this thing done. I'm ready. You need to center drill it. There we go. I hope that's good enough. Otherwise, it's a lot of work to mess up. I think it's good. I mean, I think it'll work. You use 2 machinist jacks. You know, you don't have to have standard pair bought jacks. A lot of times these little machinist jacks, well, yeah, they're just a nut and a bolt, but a lot of times they come in handy, especially when clearance is an issue, much shorter. So you know, make a simple set. All right, and it's time to take this over to the mill and test it. This fit, I think, hope should be all right. That. Get on there. Everything is just so close. There we go. Hopefully that works out. Actually, don't look too bad. Actually, that looks pretty good. And that shaft. Yeah. I should have made that too, instead of making this shaft. Let me bring it a little closer. I've got a gap here, which was on the original one. They had this bronze washer in here, and I should have made this a little tighter. I should have not used a washer or made this for a washer at all. So I think what I'm going to do is, after I assemble this, measure that gap and make a washer to fit tight, because I want the butt of this, or the end of this, to be butted up against that shoulder of this shaft. You know, shoulda, coulda, woulda. But anyway, that's pretty good. Let's, man, that looks really good. It's not perfect, but it looks pretty good. Let's ream this hole out. All right, I'm just going to be using a little T-handle reamer, and man, I'm really surprised it turned out that good. But to be honest, I was not interested in messing this shaft up after all the work that I've done on it. So I'm just going to ream this by hand until I start cutting on the original, and hopefully my tapered pen that I have will work, or otherwise I'll have to get one. I should have already done that, but I failed to. There's always so much to try to keep track of. It's easy to overlook something as simple as a tapered pen. Now, I did a practice piece with this reamer, and it actually cuts surprisingly well. Look at those chips already, and that's just by hand, so no reason to do this on a machine. You'd probably over ream real quick, would be my guess. And to be honest, if this didn't work, I was just going to stick a bolt in this thing. Although, I really don't want to do that, because a tapered pen seems to, well, there's no clearance required for a tapered pen, and you don't get a sloppy fit. Looking pretty good. My buddy Jim Lichty lent me these tapered pen reamers, and I really appreciate that, because I did not have what I needed. And I'm gonna have to flush this thing good. Get chips and stuff in the bearings. Well, I'm just gonna continue reaming this until I get the fit that I want, then I'll bring it back. Alright, so I'm getting really, really, really close, and all I need to do is open this up just a little more. I just want this pen to, stick above the surface just slightly, but I want it to go through all this piece. I want it to be tight in the shaft and tight in the lower section. That way it's, bound all the way through. That's the idea. And I'm almost all the way through. So I'm just going to continue working this. Just pushing down the hand. And just reaming a little at a time, because it'd be real easy to overdo, I think. It's actually the first tapered pen I've ever done. ream a little, and then stop and check. These pipe cleaners are really good. I don't want to blow compressed air and blow all these chips everywhere. That should be basically it. Yep, that is it. So I'm just gonna, once I final assemble this, I'll just drive that in a little and it'll be locked and it'll be good to go. I think that's pretty common sense to put your tapered pin in from the top, so even if it does get loose, it won't fall out. If you was to stick it in from the bottom, if it got any bit loose, it'd fall out. So it's pretty neat. I'm glad that worked. Well, that has worked out exactly the way that I wanted it to. Here's the tapered pin. Slide it in, and when they bottom out, I mean, you can tell it's just a solid thud. So let me show you. Just barely above the surface. Originally, the pin stuck up higher than that. I'm using the original pin. I just reamed it a little past what it was, and now that fits perfect. Coming out the bottom, just barely. And it seems to, everything seems to operate the way that it should. Just situated. Nice and smooth, the way I wanted it. So, that took a lot of time, a lot more time than you would think to get that set up, to get in, and didn't even get it perfect, but it got it close enough to where reaming just a little extra made the difference. But it took a lot of time to set this thing up and get the proper placement on this shaft, because, like I said, I think originally they just, hand drilled it, reamed it, and then pinned it, because, it wasn't centered, or at least, that's the way it appears. It's just my opinion, but that's what I believe. But there we go. That's what I wanted. All right, so if I could say there's one big oversight that I made on this shaft, that is not accounting for this washer that they had on the original. Now, I made this shaft to the dimensions of the original, but somewhere in the mix, I was like, well, I'll do away with that washer, make this shoulder up, to where it fits tight against this edge, and somehow I just didn't do that. So now I'm going to have to go in and try to repair this, or make it better anyway. It broke here to begin with, so I want this shoulder to be tied up against this. So I'm going to make a custom washer that fits in here, and then when I drive this pin in, that it's just big enough to where it sandwiches these two together. So I'm going to make I guess you'd call it a shim real quick to take up this excess space. I'm going to make it on the lathe. I may show you a few clips of it and surface grind it to thickness. That's the plan anyway. So just a quick repair to my repair. A little warm. Alright, so grinding this little thin washer was kind of a learning experience for me. I don't have a lot of surface grinding experience or anything like that, and this thin washer did not want to attract to this magnet very well. So I had to use some super glue. You can see it on the bottom right hand side of the screen sitting on the table of the surface grinder, and I used that in conjunction with the magnet to hold this thing. But I still took it really easy, just real light cuts and a small end feed. So, took it slow. It really worked out. I measured over it with the depth mics over top of the washer and measured off the magnet. Turned out pretty good. I was actually really happy with the way it turned out. But you got to be careful grinding these small parts. The surface grinder will throw them right off the magnet if you're not careful. So, got my washer made, and it mates up really good. Takes up all the space that I left in there. And when I drive this pin in, it should ever so slightly press up against that washer and keep everything tight. At least that's the plan anyway. Better than no washer at all, I think, or open space. Let's get this thing aligned. And our pin. Well, gotta put my key in first. That would help. Key. There's a key in this shaft down here. Need extra long fingers for that. Get in there. Okay, I think that's it. That is it. I have to put the pin back in the brake hub. It looks really good. And operates the way it should. So I gotta get this tightened up, get my pin in here, and then get my pin in the brake housing. I remember that this was not tight. It just had a pin in it. Tightened up as far as you can. That's the way it was. And then it had a pin in it. Hopefully. Yeah, there we go. No reason to get crazy with these, they're not going to get hung on anything in there. Don't need bent flat over, so there you go. And that works pretty good. Now I got to put the pin in this, but before I do that, there's a really long shaft that runs out of here, and connects to the clutch on the other side. So before I do that, I don't want that big shaft swinging around. I'm going to have to clean this guy out. I want to be able to handle it. Nothing's going to fall apart as it is, so there we go. And it's nice. And I got to put my spring detent and stuff in here, but that's, simple. Yeah, there we go. And space to get that pin in. Yeah, they did. Just enough. Here we go. So that's pretty much it, really. The shaft, I think, is done. Can't move it now that the detent's in there, but you get the deal. You know, I operated it hand with a detent. It felt good to me. The detent actually, when you release the clutch, that roller kind of sits on that tapered top of the detent and pulls the brake and everything in. So, you know, it's got slight brake pressure all the time when the clutch is released. That's the way it works. So pretty neat. And that was a big job for sure, but I enjoyed it. All right, guys, I got some viewer mail I want to share with you, and I got some letters that I want to read. I'm going to try to make it quick, but I want to share this stuff with you. Okay, first off, I got sent to me, this was through Instagram, but he's also a follower on my YouTube channel. This is an inch and a quarter to 50 taper horizontal mill arbor. Now, I did not have one of these. All I have is a 50 taper to inch and a half, which I don't have any inch and a half cutters. So this is, you know, great. It's got a little damage, but you know, it'll probably be fine. It was a gift, so I really appreciate it for sure. And it is, hey Mr. Summers, my name is Rowan. I've been following you since the Super Heavy Shaper Cuts video. I love your channel, and I'm excited for you to get your new K&T mill. I hope this arbor serves you well. I'm 17 and I have a small Clausing 4913 10 by 36 lathe that I saved my money for when I was 14. It's pretty good. I wish I would have had a lathe at 14. I got a hard-hinged TM horizontal mill at 16, but sadly sold it because it was highly modified and the parts I needed were sadly bought by someone on Instagram, I guess. Sorry for not sending this out sooner. I've been super busy with school and projects of my own. Sorry for the bad handwriting. If you want to, you can read or show this on video. Well, I do want to, and I just did. So thank you, Rowan. I really appreciate it, and I needed one of those. It could not have come at a better time, because otherwise I would not have been able to use that mill in a horizontal position. So, this is Mike Ray at Practical Metal. I actually think I watched one of his videos the other day. And he sent a little letter. It says, love the content. I too have a K&T H2 horizontal mill. Your videos series has made my project less intimidating. I have to pull the motor and I now feel I have the info that I need to get it done. Got your stickers, and here are a few of mine. Hope to get a good spot. Mike Ray. Well, Mike, I will give you a good spot. I will stick your sticker right there, and I think that's pretty prime real estate. I'm actually running out of room. I need to get a bigger sticker board. So thanks, Mike. Everett from Everett's Workshop sent me a couple stickers and a letter. And it says, hi Steve, I mostly wanted to send you a couple of stickers as I thank you for sharing what you do. I appreciate that you're just a regular guy who wants to be a good husband and dad while sharing your hobby with the rest of us. I've learned as you've figured stuff out. Please don't feel pressured to plug me or my channel. I'm still early in on YouTube and just got to making stickers after being asked by others to make them. Got more projects drawn up, but like, a little messy there, Everett. But like all of us, need more time to get them done in among life's events. So thank you again for everything. Take care and don't be a stranger. P.S. My wife Christina thinks Elizabeth is awesome. Well, Christina is not alone. I also think Elizabeth is awesome. So thank you, Everett. Go check out Everett and Mike. Okay, and last but not least is Stephen Lang from Shark River Machine. So go check out him. He's got a YouTube channel. I follow him, and he follows me, and he's also a patron of mine, which is amazing because every penny makes a huge difference, especially with me. He sent me some tapered reamers, which are number 3 through number 8, which is really nice because I definitely needed them, and I look to need them more in the future. we used a number 6 on this project here. We didn't use one of these because I did not get them. I just got them today. The tapered reamers I used on this project were actually sent to me on loan by my buddy Jim Lichty. We used the number 6, so thank you, Jim. I really appreciate it. They got me by on this project, and I appreciate you sending them out for me to use because I did not have the size that I need. So I think, that's it. So thank you guys. I really appreciate it. I will get your stickers up, and I'll save the letters. I always do. So I appreciate it. Well, guys, I think that's about it this week. I think I made really good progress. Those setups, or that setup, trying to get that tapered pin back into that original position, that took some time. You got to see the final setup, but it took me a little while to get that dialed in to where I was happy that when I drilled that hole in this new shaft, that I wasn't going to scrap it, because that was a lot of work, and I did not want to scrap it in front of you. But I think it'll be just fine. That I can't see that shaft breaking now without abuse. I mean, it is a pretty heavy setup, and there's a lot of these mills out there that are still running that have never broke a shaft. So I think this one will be just fine. I mean, we'll see, and I guess so will you. So big thanks to all my viewers. I really appreciate you guys spending an hour or so with me every week, and I enjoy doing it. Big thanks to my patrons. You guys are awesome, and I really appreciate you guys throwing $1 in the hat. It definitely helps to keep the lights on and keep a little heat in here. It makes it a little easier for me to come away from the family and come out here and shoot some film. Although I do it because I want to. I mean, you get the idea. It helps, and I appreciate it. So thanks again, and I really appreciate you watching. If you have any questions, make sure to leave them in the comments. I love reading through them, and I love replying when I can. If you need anything, contact me through my email, and click on my guy to subscribe. Hit the bell for notifications, and as always, I'll see you next time.
Like a bird on a tree.